So now we're joining an old friend of ours in Virginia, just across the road from the United States nation's capital. If we can bring in Dr. Grae, Seth Grae. Do we see him?
Hello, Mungo. It's good to see you.
Ah, there you are. Seth, I'm going to just give you a 2-minute introduction because a number of people have asked me, they've said, Mungo, why are you so enamored with Lightbridge and what they're doing? And if I could give just 2 minutes and then hand over to you, because it is very special to me. We met, if somebody had asked me 5 or 6 years ago, or told me 5 or 6 years ago, you're going to fall in love with nuclear technology, I would have said, forget it, absolutely no chance. And then I met Lightbridge. The biggest issues I had with nuclear were it's not safe, it's not commercial, the spent fuel is a pollutant, and the spent fuel can be used to make weapons. And absolutely, as far as I'm concerned, we're out, we're not doing it. Then I met Seth. And Seth said, well, we're doing it slightly differently. We're changing the fuel. We're not changing the reactors, we're changing the fuels. We are creating a fuel that can go into existing reactors and new reactors which are built specifically for our fuel. Instead of processing at 1300 degrees, it's processing at 300 degrees. And Seth reminds me that that's the temperature of a pizza oven. So if you're going to shut down these reactors, you've got to shut down every pizza oven in the world as well. He also says that the revenue generated will be some 30% higher, and the cost will be no higher. In fact, when you build the optimum reactors, the cost will be lower because the balance of plant is different. This fuel has been rated by experts as absolutely impossible to weaponize. That is absolutely key to this. And furthermore, the technology for reprocessing fuel is now advancing to the point that seems it will merge with Lightbridge when Lightbridge comes on. Now, one of the things that I've been lucky about, I've spent 20 years working in the biotech industry, which means you can take 15 to 20 years to actually get something to the market. Seth, I believe, started this in 2011. We're now 10 years later, and my understanding, and this is what he's going to explain to you, is where the company is. I say we, because we have a very close relationship here, but where the company is actually in that certification process. And it looks like almost to the month, almost that it's going to be 10 years, then Seth will tell you everything else. But this is very, very, very exciting. And Seth was a winner 3 years ago. Seth very generously said, please, we do not want to be up for an award this year. There are many others who deserve awards. Seth has already won an award, but you're coming back here next year, okay? And you're going to be up for an award for a later stage award, definitely. I'll stop. Seth, thank you for joining us so early in the morning. Over to you.
Well, thank you so much, Mungo. It's an honor to participate in CleanEquity again. And I'll tell you everyone a bit about Lightbridge, and happy to engage in any discussion you'd like to have as well. So at Lightbridge, we are one of the only pure play nuclear companies on the public markets. We're listed on the NASDAQ stock exchange in New York under the ticker symbol LTBR. And we're seeking to impact the world's climate and energy problems soon enough to make a difference, to allow for the availability of massive amounts of clean power to meet the IPCC goals soon enough to help prevent the 2 degrees C threshold from being crossed by 2050. I'll refer you to our safe harbor statement and say that what you can see here is an image of some of the rods that we've produced, which look very different if you know anything about what is currently used in reactors, which are pellets stacked up inside tubes. There are no tubes with Lightbridge fuel. There are no pellets stacked up. This is a very high technology product with several zones within one extruded metallic rod that helps provide significant safety, economic, non-proliferation, and other benefits without a change to the reactor. This fuel can be used in the existing reactor and in new ones that will be deployed, including the small modular reactors that are coming. Here's a photograph of what the rods look like assembled into one fuel bundle that can be put into a reactor. There are different variants of the fuel bundles for different types of reactors in the world. And one of the benefits that this fuel provides is that it can help provide reactors with the ability to load follow, to ramp up in power very quickly, ramp down in power very quickly in ways that current reactors can't. So this fuel can allow the reactors to be paired with renewables on the electric grid. And as the sun shines or the wind blows or doesn't, or as demand comes online and goes offline as air conditioning is needed, et cetera, reactors with this fuel can very smoothly and quickly go up and down in power to match with renewables and power demand on the grid. As Mungo said, this fuel operates at a much lower temperature than the current fuel does in reactors, about 1,000 degrees Celsius cooler down the center line of the fuel rods. And that's part of what provides these massive safety benefits. Along the right side of the screen, you see some quotes that are currently on the United States Nuclear Regulatory Commission's website about Lightbridge fuel. One of them, that middle bullet, says, for example, complete retention of fission products means no burst release of these products upon cladding failure. You might have seen in the last few weeks that this is exactly what happened in a reactor in China, where some of the fuel rods broke and they had fission product gases with radiation released into the plant and apparently a bit into the environment. A similar incident, first of all, we believe would not happen with Lightbridge fuel, but even if it did, you wouldn't have that release of fission product gases and radiation. Just one example of a major nuclear safety regulator touting one of the benefits of Lightbridge's nuclear technology. And right now we're focusing on both the design and qualification of this fuel to commercially deploy it, as well as manufacturing of the fuel. And we're very fortunate right now to be operating under what's called a gain voucher from the US government, from the Department of Energy. And this particular gain voucher that we're working on right now is allowing us to design an experiment to insert fuel samples into the Advanced Test Reactor, which is the world's largest test reactor. It's at Idaho National Laboratory in the United States. 3/4 of these costs are paid in cash by the US government. 1/4 is provided in engineering time by the United States. And this will be to prove out the fuel in these reactor conditions for the parameters of this test. We are also, however, one of the only companies to be operating with 2 gain vouchers simultaneously from the US government. This week we announced signing the contract that will allow us to start work under this second gain voucher with a second US National Laboratory. In addition to the work with the reactor at Idaho National Laboratory, we'll now be starting at Pacific Northwest National Laboratory, demonstrating our casting process with depleted uranium that the US government will allow us to be using in this process to demonstrate a key step in the manufacturing process of the fuel. So while we're qualifying it, we're also demonstrating manufacturing of it, which we hope will allow us to bring this to commercial reactors by the end of the decade. You've probably heard quite a bit about small modular reactors coming that are much smaller than the very large reactors, including some not very far away from Monaco in France. And these small modular reactors will have many benefits, including the ability to have the major reactor components produced in factories or shipyards and shipped to sites so that they can be deployed in very large numbers with much lower costs than deploying large reactors. And we believe that large numbers of small modular reactors will be necessary for many countries that now don't have nuclear power to be able to obtain it, to allow the world to achieve climate goals pairing with renewables on the grid. And at Lightbridge, we have a particular focus to help also bring our fuel to these small modular reactors in addition to the large ones. So with Lightbridge fuel, the small modular reactors can load follow, surge up and down in power with demand needs and as renewables come on the grid. But we'll also bring these tremendous nuclear non-proliferation benefits that Mungo spoke about to these reactors so that they could never be weaponized. These small modular reactors with Lightbridge fuel would produce more power than they would with current fuel in reactors, and therefore would have a lower levelized cost of electricity, a lower cost per unit of electricity generated by the plant to make these economically competitive and viable to deploy worldwide. One case study we show on this slide is that a small modular reactor with a power uprate provided by Lightbridge fuel could be used to generate hydrogen that can be used in zero carbon liquid fuels that could replace carbon-based liquid fuels in hard to decarbonize sectors like aviation and shipping. This slide uses numbers relating to large reactors, which we believe will scale for the small ones as well, just showing how much money per year we believe a current plant would economically benefit in US dollars from switching from current fuels to Lightbridge fuels. And I'll finally just mention that we have a world-class leadership team, very experienced in nations around the world, from industry, from government, and very qualified to oversee this project, bringing it to market. We're always happy to have people from CleanEquity participants reach out to us. You can reach us at ir@ltbridge.com, and we always look forward to discussions. And with that, Mungo, if there's anything further you would like to discuss, I'd be very happy to do so.
Look at that, spot on nuclear time. Well done, Seth, thank you very much. I have only one actually comment. Thank you. I'm sure there will be questions and things that will come up, and what we'll do is we'll field them, allow you to get some breakfast, and thank you very much and well done. And actually, one question. When do you think we will have the next piece of news? I call it the phase 3 because this is the final federal process that they have to go through to get approval. So when do you think your phase 3 will be? We'll have some news on that.
Well, I think we'll have some further news of our cooperation with the US government this year as we're proceeding on the work under the 2 gain vouchers, and that will provide the data that we will use to bring to the Nuclear Regulatory Commission for the licensing process. And I think you'll see a lot more news in the next year along those lines.
That's great. Seth, thank you very much. And again, congratulations on all the hard work.
Thank you. I look forward to being there next year.
Thank you very much. Seth did actually remind me of something which I neglected to say this morning. I'm obliged to inform you when we're talking about a public company. Seth did inform you that Lightbridge is a public company, Taranis Fuels is a public company. Everything that you have been told today is somewhere in the public domain, so you are not sharing confidential information that you shouldn't have. So thank you very much, Seth, again.
Thank you.
And we'll be in touch later.